welcome back to another video on double A learning. Today we're gonna stick to a calculus topic again and stick with the concept of integration, but this time go with integration by parts. So before against this video, integration by parts is basically another way of integrating, and it's more like advanced level, I would say. So like for high school, like calculus BC, or like in college level, like a Calc 2 class or something. So basically, what integration by parts is based on the product rule of differentiation, which we know, but is reversed for the integration purpose. Okay, let's get into the formula you guys have to know. So the formula for integration by parts is the integral of u dv is equal to uv minus the integral of v du. Okay, let's talk about some of these parts. So to get from u to du, you just have to differentiate this u to get that du. So just simply differentiate. And then to get from the dv to the v, you basically just have to integrate. Okay, so yeah, that's the formula. And then when you guys are using like actual numbers for this formula, there's actually like a specific order that you guys have to integrate when you're like tasked with this. So there's an easy mnemonic that I like to remember. It's called LIPET, LIPET. That's how I like to remember it. So the L stands for logarithms. So if you have a log or a natural log, you have to use that as a U term first. So basically what this mnemonic does, if I didn't explain properly, is like it tells you what to use as your U value first, and then later as your dv value. Okay, so this is the log. L would be log, I would be inverse trig, and then P would be polynomial, any polynomials. E would be exponential, and then T would just be trig. Okay, so for a log, just remember like natural log, log, just logarithms. For inverse trig, think of like sine, inverse, tangent, inverse, etc. Polynomials, it can be x squared plus 1, literally any like polynomial. Exponentials can be like e to the x, and trig can just be like, again, sine of x. So when you guys have to decide between what's going to be your u value and what's going to be your dv value in an integration by parts like question, you guys make sure you like choose LIPET. You think of LIPET and be like, okay, is it log first? If it's log, then what's the next closest one? Inverse trig. It's inverse trig. If yes, then that's it. If not, is it a polynomial? Basically keep going in order. Okay, let's get into some practice problems now. Okay, so my first practice problem I have is integral of x times e to x dx. Okay, as you can see with these type of questions, it's always like you're multiplying two things. That's when you have to use this integration by parts. Okay, so what would we make our u value and what would we make our dv value? So we would have to use LIPET first. Let's just write it out. LIPET. Okay, so do we have a logarithm here? We don't have a logarithm. Do we have inverse trig? No, we don't have inverse trig. Do we have a polynomial? We do, and that's the x value right here. So that's where the u value is going to be the x. Do we have e? Yeah, the exponential is right here. but we have a polynomial that comes first. So our u is going to equal x. And our dv is going to equal e to the x. Okay. Now we need to find du. So let's just write du. And du is just the derivative of x. So we know that is just 1 dx. And then we need to find v. So we just got to integrate e to the power of x. And the integral of e to the power of x is simply itself. So that just becomes e to the power of x. Okay. Now we have to use our formula. And if you guys remember our formula, it's u b minus the integral of v du. Okay, so what's our u term? Our u term is x. I'm just going to do it in parentheses to make it easier. And then v, our v term is e to the x. And minus the integral of v, which is e to the x, times du, which is 1 dx. Okay, now we could rewrite this as x e to the x minus the integral of e to the x dx. Now let's just treat this term right here. So we know that the integral of e to the x dx is simply e to the x, because the derivative of e to the x is e to the power of x, and then the integral of e to the power of x is e to the power of x. It just stays the same the whole time. So the final answer for this would be x e to the power of x minus e to the power of x plus c. And that is our final answer for this question. So yeah, it's like these questions are you have to notice a pattern when you have to use this. So here we obviously knew we had to use it because we're multiplying the two things. Whenever you're multiplying the two things, it becomes easier to use this method. Okay, let's go to the next question. Okay, our next question is going to be the integral of x squared e to the power of x. Okay, same process. We have a polynomial here, so let's just write Lipet here, just so okay. So we have a polynomial x squared, so and then an exponential of e to the x. So our u value is x squared. And then our du then would be 2x. Then our dv is equal to e to the power of x. Our v is equal to e to the power of x. Okay, we have this information now. Now we just have to plug it into our formula that we know. So our formula again, let me write it down, is uv minus the integral of v du. Okay, so it would be x squared times the e to the power of x minus the integral of v e to the power of x times du. 2x, you have to add the dx here, dx. Okay, so when we want to integrate this, it won't simply turn out like the last question we did where it was e to the power of x. So let's just leave this term right here. Let's just leave it here. But let's integrate e to the power of x times 2x dx. So what you guys have to do sometimes for these problems is a double integration by parts. So in this case, we're multiplying again two terms, and we know 2x is a polynomial. So we basically have to use different variables or label it differently when we're integrating by parts again. So we used u here. I'm going to just do u2 with a subscript, just so that when my grader sees the paper, they know, okay, these are different terms. They're not using u again, because we already used u for this integration right here. So this would be u subscript 2, and we know that's 2x. And then we'd have to do the same thing for everything. So du 2 would be equal to 2. And then 2 dx, sorry. And then we know dv 2 is equal to e to the power of x. And then we know v is equal to e to the power of x, v2. Okay, now again, you guys just have to do integration by parts the same way we did. So we know the u value is 2x, v value is e to the power of x, minus the integral of v e to the power of x du 2 dx. Okay, now this is easier for us to integrate. All we have to do is keep this 2x times e to the power of x minus, we move that 2 to the front, the integral of e to the power of x dx. And then this just becomes 2x e to the power of x, let me just add parentheses, minus 2 e to the x plus c. But we're not done, because we still have this part, which we gotta move right here and put it in the front. So this becomes x squared e to the x. There's still that minus sign as well. Minus, and I'll just do brackets here to make it more clear. 2x e to the x minus 2e x, and then plus c. Oh, let me rewrite that better. Plus c. Okay. Again, we remember we have this part from the beginning where we use integration by parts here. So now we did a second integration by parts for this step right here. That's the reason we have these like almost 2 parts of the uv. So we can simplify this by distributing the negatives to both of these. So when we do that, it becomes x squared e to the x minus 2x e to the x plus 2e to the power of x, and then plus c, and that will be our final answer. Okay, yeah, sometimes you guys just have to know like when to do these double integration by parts, and yeah, it could be sometimes a little tricky, but with like I feel more practice, it'll get like better. And I'll have a link again in the comments to a worksheet where you guys can review. Okay, let's go to our final practice problem. Okay, so this one is the integral of x cosine x dx. Okay, let's write LightPet again, just because we need to have it for this problem. Okay, do we have a log? No. Do we have inverse trig? No. We have a polynomial in x, so these rests don't matter, but we also have a trig, just really like we're aware, cosine. So our u would be x, our du would be 1 dx, our v, we don't know that yet. First let's label our dv. Our dv is cosine x, and then our v would just be sine x, because we're taking the integral of dv. Okay, so, and the reason it's sine x is because the integral of cosine x is equal to sine x. If you guys need a review on that, go to my video on trig integrations that I made. Okay, so let's just do the same integration by parts method. So again, I'll write down the formula. So it's uv minus the integral of v du. So the u value is x times the v value, which is sine of x, minus the integral of v, which is sine of x, times du, which is 1 dx. So we can rewrite this as x sine x minus the integral of sine x dx. And then simply just take the integral here. And we know that from the integral of sine x, all we should know is equal to negative cosine x. So this will become x sine x minus negative cosine x plus c. And then we can rewrite this as x sine x. And because there's two minus, we can turn that to a plus cosine x plus c. And that is our final answer. Alright, whenever you guys do these problems, make sure you guys simplify it like fully. Most of the ones I had didn't really much require that much like in-depth simplifying. But in like the practice problems I'll have, make sure you guys simplify it like to make sure for clarity's sake. And yeah, that's the end of the video. Hope you guys enjoyed. Thank you so much.